So in this video, we are looking at what we call the 68, 95, 99.7 rule. Now, we said in the previous video that all normal distributions look the same in the sense that they're symmetrical, they have the same shape of the data, but what distinguishes one from the other is the mean and standard deviation. Now, these two things are really important and they have to do with the percentage of data lying in different sections of our normal distribution. Now, we have here that the percentage of data that lie within a certain number of standard deviations or z-scores, we'll talk about this idea of z-scores in future videos, is always the same for a normal distribution. So for a normal distribution, it says here that within one standard deviation of the mean, we'll show what this looks like in just a moment, 68% of our data lies within these. So one standard deviation above the mean, one standard deviation below the mean. 95% of data lie within two standard deviations of the mean, and 99.7% of the data lie within three standard deviations of the mean. Now, we can also think of splitting our data in half, where 50% of our data will lie above the mean and 50% of the data will lie below the mean. Now, we're going to do one example, and I've got this kind of visual cue here to hopefully help us to sort of understand the points above and kind of always refer back to this normal distribution. Now, remember, the two things that distinguish a normal distribution from another is the mean and standard deviation. So this has told us that the data has a mean of 75 and a standard deviation of 5. Now, the mean of a normal distribution lies in the middle, right? Because remember, in this middle point at this peak, that's the mean, median, and mode, and they're all equal for a normal distribution. So we're going to write that the mean is 75. So this score right in the middle is 75. Now, 50% of this data, they've told us, lies above blank, so above a number. Now, we said that the mean splits our data in two on our normal distribution. So 50% of the data, this entire section here, is above our score of 75, is above our mean. So we can say that 50% of data, so 50% lie above 75. They lie above this score. Now, part B is saying 68% lie between, and we need to put two numbers in here. Now, 68% of data, we know from that dot point earlier, lie within one standard deviation of the mean. Now, if our standard deviation is 5, then that means a score of one standard deviation above the mean is going to be a score of 80. One that is one standard deviation below the mean will be 5 less than 75. So that will be 70. So here, in this section here, within one standard deviation of the mean, so on each side, 68% of data is located in this highlighted bit here. But we can write here that 68% lie between 70 and 80. Okay, let's clear this. Now, and saying 95% lie between two numbers again. Now, from our dot point, 95% of data lie within two standard deviations of the mean. So that is going to be from up here all the way to down here. So, two standard deviations above the mean. We said that this first one was going to be 80. Then another standard deviation above, we're going to add 5 again. So this is going to be 85. And in the other direction, we said this first one was 70. So another standard deviation below the mean, we're going to subtract 5. So we're going to get 65 here. So based on our normal distribution and the features of the standard deviation and how our data is distributed, in this shaded bit that I've drawn up here on our normal distribution, 95% of our data is going to lie within this. So we can see takes up most of the actual data. So this is between 65 and 85. And finally, 99.7 lie within 3 standard deviations of the mean. So we're going to extend this stuff a little bit further. 3 standard deviations extends to here and extends to here. So we're just going to add 5 again because each 1 standard deviation away from the mean, we add 5. So this last one is going to be 90 up the top here and 60 on the bottom. So 99.7% of our data lies between 60 and 90. So this is how we can navigate with reference to our normal distribution. And in the later videos, I'll always kind of go back to this bell curve as a nice visual to remember when you're going through these types of questions. Well, that brings us to the end of the video. Thank you so much for watching, and I'll see you next time.